Hello everyone, my name is Peter Lyons and this is lab number 5, our last lab, which was a choose your own adventure lab in which I will be exploring projectile motion. So in this lab we're going to observe a weighted mass or a lacrosse ball being tossed through the air and then compare the motion with Newton's second law. So a quick overview of projectile motion. Any object's motion can be broken into an x, y, and z component. So to find the magnitude of said force, you would find the square root of the sum of the squares of all three components. But we do not have a z component in this case because we are only worried about the x and y component of the motion. Now, looking at my video and tracker, you see me on the right about to throw a ball to my friend. Shout out to John Stacy Walsh III. I've set the origin to be the point at which the ball leaves my hand, and I've set a calibration stick on the clock with the diameter being 0.288 meters. When we press play, we see that the ball leaves my hand and moves in a parabolic motion with a constant x velocity and a changing y velocity, which changes due to gravity. The way we can see that the x velocity is constant and the y velocity is changing is by analyzing the graphs of the x coordinate and y coordinates over time. You can see that the graph of the x-coordinate over time has a strictly linear slope to it, showing that it has a constant velocity, whereas the parabolic slope of the y versus time graph shows that the velocity is changing due to gravity. Running my computer model, you will see a blue ball moving in a parabolic arc in the negative x direction. You will see a yellow arrow representing the velocity in the x direction and a black arrow representing the velocity in the y direction. You will notice that the x velocity stays constant while the y velocity changes over time, and this is because gravity is constantly acting upon the ball, which is bringing its y velocity down. The x velocity I obtained through tracker, which was negative 2.8478 meters per second, which I took from observing the slope of the x position over time graph in tracker. The y velocity I calculated to be 4.49 meters per second, which I obtained from solving the below equations. When it comes to projectile motion, there are two components of energy of the system, which are gravitational potential energy and kinetic energy in terms of a point particle system. Now, when the ball hits the top of the parabola, it hits a point where the velocity is 0 and the gravitational potential energy is at its max. And then there are 2 points where the kinetic energy is at its max, which are when it is leaving my hand and when it is hitting Jesse's hand. So we can set the gravitational potential energy to the top of the parabola equal to the kinetic energy as it's leaving my hand, and we can solve for the initial velocity from there. This gives us a magnitude of total velocity of 5.32 meters per second, which is backed up by my computer model. This relates to Newton's second law because just like motion, net force can be broken down into x, y, and z components, and these components of the net force only affect their respective components of motion. Putting the data from my computer model and the data obtained from tracker into Excel, you can see that the computer model fits the tracker data almost perfectly. Slightly underestimates the tracker data, and this is most likely caused by a tracker error on my part. And that is the end of my last lab of this class. Thank you very much for watching.